Maybe not everybody knows that for the past few decades, lakes and rivers of the border region of the world are experiencing a phenomenon called brownification. Brownification refers to the tendency of inland water to shift towards yellow and brown shades. This is the consequence of an increased concentration of dissolved organic matter of terrestrial origin into the water. Since the organic matter absorbs their solar radiation in the ultraviolet range, the water gives back the yellow-brownish color. But how does the organic matter move from the terrestrial compartment to the freshwater system? The organic matter present in the soil primarily comes from the degradation of plant material that, once in contact with water, can release humic compounds in solution. Think about what happened when you dip a tea bag in water. The water changed color, isn't it? Well, that color you're looking at is actually dissolved organic matter. Now, why is the dissolved organic matter increasing in lakes and rivers? One of the principal causes is the climate change. In fact, the increasing frequency and intensity of precipitation facilitated events of surface runoff, which is enriched in organic substances compared to the groundwater, while the increase in temperatures promote terrestrial primary production that enhance the content of soil organic matter that can be dissolved. But what are the consequences? One of the major problems is the loss of biodiversity and decrease of ecosystem function. Let's take the example of a lake. The brownification of a lake corresponds to a diminished penetration of solar radiation into the water column. This causes the death of macrophytes, such as lotus or water lily, which give refuge to prey fishes that eat on zooplankton, which feed on algae. Then prey fishes being eaten by predatory fishes, there is no control over zooplankton growth that are free to overfeed on algae. The consequence is the bloom of cyanobacteria and other bacteria, with impoverishment of water quality for recreational purposes, and with risk for human and animal health. Also, some predatory fishes rely on visual hunting to feed, and if the water turns too dark, it might cause the death of those species, which are usually of higher value for fishermen. Another consequence is the increase in surface water temperature due to UV light absorption by the dissolved organic matter that drive the lake towards a longer and more stable thermal stratification during summer. The lack of water mixing increases the potential for anoxia of the bottom layer of the lake, with increased risk of death for benthic species that populate the sediment and the water standing over it. But let's consider pristine lakes, such as glacial lakes. They are very low in dissolved organic substances and are depleted in nutrients, hosting little primary production. Here, an input of dissolved organic substances would represent a source of nutrients that will stimulate life. Overall, high level of dissolved organic matter in water can cause loss of plant and animal species and then biodiversity, but at lower concentration, it represents an important source of nutrient that can boost life in a lake. Overall, high level of dissolved organic matter in water can cause loss of plants and animal species and then biodiversity, but at lower concentration, it represents an important source of nutrients that can boost life in a lake.